This example wants us to find the limit as x approaches 0 of this equation, 1 minus cosine of 3x divided by 5x. The first option, I always call option 1 on any limit problem, is really you just want to go ahead and plug that value in, whatever they're giving you here for x, in everywhere you see an x in the equation. Sometimes that works, and you'll be surprised how often it does. So in this situation, you'd plug 0 in for x. We'd end up on top with 1 minus the cosine of 0, which would be 1. So 1 minus 1 gets us 0. On the bottom, we get 5 times 0. So option 1 fails us because we get division by 0 on the bottom, right? That is the biggest no-no in all of math. And so what we want to do now is try to find an alternate method. When we look at this problem, we really want to recognize that we have this 1 minus cosine of something going on up here. And really sort of bells and whistles should be going off that this comes from our cosine limit definition. This is not a very common one, but it shows up on the exam every so often, and so it's definitely worth remembering. So this says the limit as x approaches 0 of 1 minus the cosine of x divided by x. We have a definition for this, and they tell us that this equals 0. The key with this is kind of understanding that it doesn't really matter what's inside the cosine as long as what's inside the cosine is matching up with what's outside the cosine. The other thing to know about this is it can work in both directions. So while we've written it with the cosine on top, it really also, the same definition applies if this was 1 minus cosine x on the bottom. That would all still equal 0. So we're going to take this problem on now sort of using that method. So we'd say, okay, I've got the limit as x approaches 0 of 1 minus the cosine of 3x divided by 5x. The critical piece on this is we need to get it so that the outside x portion matches the inside x portion. So when those pieces match, that's when this definition works, and we can just call this thing 0 here. We cannot get at that 3x on the inside there. There's really not much we can do to that to change how it looks. And so what we're going to have to focus in on is this 5x piece and making that a 3x. This is really just a little algebra move, a little multiplier game that you'll play. And so what you'd say to yourself is, okay, I need to cancel out that 5. So to cancel, you'd want to multiply by a 5 on the bottom of a fraction. So those would cancel out there. And what I need left over is I need there to be a leftover 3. So I'm going to multiply this bottom piece by 3/5. Well, whatever I do to the bottom, I have to do to the top. We got to keep this thing in balance. And so we'll come through here now. We'll kind of simplify this algebra that we have. So limit as x approaches 0. On the top, we've got 1 minus the cosine of 3x and then times 3/5. We don't really want to multiply that stuff out. On the bottom here, though, because this is all over 1 right now, the 5's will cancel, and so we're left with 3 times x, which gets us 3x. That's now going to allow us to just kind of focus in on this piece. That piece now meets our definition. We have 1 minus the cosine, we have a 3x on the inside, and we have a 3x on the outside. And so that piece there fits our definition. And so we know all of that equals 0. And so what we're really looking at now is 0 times that 3/5 that we had left over. Well, 0 times anything is just going to give us 0. And so the final answer to this would be y equals 0. The limit as x approaches 0 of 1 minus cosine of 3x over 5x would be y equals 0. And the trick to this game is just making sure you get that inside and outside matching by doing this little multiplier trick.